Hello, my name is Guy Sofer and I'm a product manager in the application modernization and connectivity part of Micro Focus. And this is a video about innovation and specifically about serverless Cobalt and some features from our upcoming release. When we're talking about core business systems modernization and innovation, it starts with this question: reuse or rewrite? We all have our business objectives. We need to respond faster to changes. We need to integrate core applications with the rest of the business, with web and mobile. We need to service enable them. We need to cut costs and move to modern consumption-based platforms and the cloud. But with these stats, 92% of core applications remain strategic, but 71% of IT projects fail. It becomes obvious you need to reduce the risk, and that means reusing what works. But that is not to say that reusing core business logic is without challenges. Isolating business logic is not easy. Mechanisms and tools are needed for exposing services and creating APIs. Integrating between the core business logic and the new platforms and third parties is another challenge. And lastly, how do we exploit the great benefits that come with modern infrastructure? How can we leverage scaling out containers and serverless capabilities, which are now becoming more and more common in the cloud? Why do we need to provision and maintain hardware capacity that is only needed in peak hours if virtualization now allows scaling up and down dynamically? So in this short 10 minutes demo, I'll try to touch on all of these challenges. We'll start with a mainframe application that has a piece of code in one of its programs that is doing a specific calculation. This will be our business logic. In this case, it is calculating which day of the week it is for a given date, but think of it as a unique Cobalt code that you want to reuse or expose. We'll then use application intelligence and business rules to easily find the needed code using online documentation that is available straight from the development environment. We'll see some new 7.0 capabilities we added for better understanding data flow by visualizing it, and the ability to get some program relationship details from a central application intelligence repository. Next, we'll use code slicing or refactoring to slice out the calculation code to a brand new program. This program will be compiled as .NET Cobalt, and this will allow us to do two things. The first is easily call it from a C# Azure function wrapper, and the second one is to run the Cobalt code as is inside an Azure serverless function. Now, I'm assuming you are familiar with serverless computing, but in a nutshell, it is a method cloud vendors allow you to run code on the cloud without the need to provision any hardware. So you don't need to define a machine size or install anything. You upload the binaries, and the cloud takes care of hardware, of scaling out when needed, scaling down when the workload is reduced, and even provide all the monitoring and analytics for it. So, time for the demo now. So we start our demo with the modern website that is calling a service that will calculate the day of the week for a given date. We haven't created the service yet, so if we'll try it right now, we'll see that it will not work. And this is calling a service on the cloud, on Azure in this instance. So let's find the code that implements the service and make it available to the website. Okay, so we have a project here with several Cobalt programs. We want to find the information of where the needed code is. So we'll use our analysis server that our Visual Studio is attached to. And there's a repository here that holds all the information about our application, including business rules information that was extracted ahead of our task. So we can see that there's a program called product update. It has a product update process, and we can go and see the different parts of this program or business rule or business function. And in this case, generating a daily report, calculating daily totals, and some initialization. And in this initialization section, we can see that there's some logic for calculating the day of the week for a given date. And we can see even the code that is attached to it. We have additional information here, like business description, that states that this can be reused in our new website. And in here, we have the business rule that actually contains the result of the day of the week calculation. So it's in product update, line 280. So we'll go to our project files, find product update, go to the relevant line in the code, and in here is the data item that will hold the information. And now a cool useful feature that we added for 7.0 is the ability to visualize how this data is being calculated. So here's a data flow graph that will show exactly how we got the result to report day of the week. So we can see the different code sections that was used to calculate it. We can navigate them, and we can understand exactly how the day of the week was calculated. And this was backtracing the data flow, but we can also do it forward tracing. So we can see how WSDD is being used in the program, how the data is actually being used. So we can navigate and see that it's moved to INT 0003, and then another time, and to the reminder data item, and another temporary data item, and we can actually visualize the entire data flow of the data that started in WSDD. Okay, now while we're with 7.0 capabilities that we added, another useful thing that we have, because we are connected to a central repository, is the ability to get some additional information about the program. In this case, get direct references or dependencies. So this connects to the central application intelligence repository and come back with information about the program, which programs it calls, which include files it uses, all the data ports that are being inserted to, reads, or updated. And this is all useful information that comes from our connection to the central repository, application intelligence repository. But now we want to create a new program from the computation that will have the computation of the day of the week for a given date. So we found where the result of the computation is going to be in the report day of the week, and now we're creating a program from this computation. We call it day of week. And we got a new program that is actually containing all the information, all the data item, and all the code that is used for calculating the day of the week. So imagine that in your application, this would be some calculations of loans or policies or anything else that is, pure COBOL code. And we can see how the new program is comprised. All the non-relevant sections of code are removed from the program, including all the data items. And in here we have 200 lines of code, of COBOL code, that is doing the actual calculation, and that's exactly what we need in order to create a service. So the next piece of magic that we're going to do is to use something that is called .NET Cobalt Projects. So A .NET Cobalt project is a project that compiles into MSIL, can be used very easily by .NET application and .NET code, and can reference also .NET framework in its code. So in order to use it, I added some linked section items. This will hold, this will be the input of the date, and this will hold the output, which is the day of the week for the given date. And we can see that when we exit this new program that we created, there's an automatic code that has been generated to copy the result into the linked section, so it will be available for the calling program. Now we could use this program and use this .NET Cobalt project in many ways. In this case, we decided to use it by calling it from an Azure function project, which is creating a serverless function that can run on Azure. So here's the project and some simple code that all it does is actually calling the Cobalt code we just saw. And let me demonstrate it to you. We'll start an Azure function emulator that comes with Visual Studio, and we'll just step through the code and see how easy it is to use this .NET Cobalt from C#. So we started a function, we got the date from a parameter, from the request parameter. Now we're creating a C# class that is actually a wrapper, an automatically created wrapper of the linked section. You might identify the names from before. And now we enter the date into this output structure. So you can see it's in ls date and in ls dd, mm, and yy, which are the day and year. And now the real magic. We step through and just continue debugging into our Cobalt code, and we can see that what we passed is available natively inside Cobalt, and the same Cobalt code that we took from the mainframe application now runs inside the .NET virtual machine, doing the calculation. Here we have the value, it is Monday, the result, and now we're copying the output and going back straight to the C# code, and I can see, and you can see that it is now available here. And if we just continue, we'll see that we got the response. Hello universe, the day is Monday. Okay, so we tested it locally, and now all we have to do is to publish it to Azure, to the cloud, and then we'll be able to see that it works from our website as well. So we're now publishing, it just zips everything up and uploads it to my Azure account. And now that it's done, we can go to our website, enter the date, for example, calling Azure now. Cobalt code is running serverless on Azure, and here is the response. And this was just the first call, so it took a few seconds, but now all subsequent calls will be very, very fast. And remember, this is actual mainframe Cobalt code running inside a .NET virtual machine, serverless on Azure. Quite cool, right? So, in order to keep it quick, I covered a lot of stuff without getting into any details, just to showcase what is possible. If you would like more details on anything you saw, please contact us and we can get to as much details as needed. By the way, this demo is based on Visual Studio, .NET, and Azure Function, but applies just as well to Eclipse, JVM COBOL, and AWS Lambda. So if you want to see this on AWS, again, just contact us and we'll be happy to demonstrate the technology. Key takeaways are that Micro Focus turns your COBOL code to be just another language. The code remains the same, but your technology and modernization choices are now wide open. You can run your COBOL code inside a Docker container orchestrated by Kubernetes, run it serverless on the cloud, easily integrate with modern frameworks, whatever works best for your organization. Thank you.